All right, this is 7th grade lesson 21 for module 6 on mathematical area problems. So we have a situation here where Patty is interested in expanding her current garden. Currently it's a 4 by 3, so what's her current area? So area equals length times width. So that's going to be 4 times 3, which is 12 feet squared. And that's it. So she wants to increase it by 3 feet long and 2 feet wide. So that means she's going to take the 4 and increase it by 3, creating a 7. And then she's going to take the 3 and add 2 more feet to it, making it a 5. So instead of a 4 by 3, now it's a 7 by 5, which gives me 35 feet squared. And that's it. So let's draw a diagram of what that garden will actually look like. So we start by just drawing a box, and this is kind of like what you guys do in science with Punnett squares. Same kind of operation. So you're going to kind of cut this up, but don't make the lines go directly down the center. Now her original garden is a 4 by 3. So we found that by saying 4 by 3 is 12. So this is her original. So just kind of keep that in mind. That's the original. Actually, let me go ahead and change that color there so it kind of stands out a little better. It's a 4 by 3, which was 12 square feet. All right, now she increased it on this side by 3 and increased the bottom by 2 more feet. So what you do is you go over the row, 3 times the column, 3. So this gained her an extra 9 square feet over here. And then here we have over the row, which is 2, down the column, which is 4, and this gave her an extra 8 square feet. And then she's got like a little bonus section here of a 2 by 3, which gives her 6 additional square feet. She probably wasn't really expecting there because it's just increasing by 9 on one side and 8 on the other side. Now she could cut that out if she wants, but I'm pretty sure she wants to keep it a perfect square. So if you notice here, if you add up 3 plus 2, you get the 5. And if you add up 4 plus 3, you get the 7. Now we found the area up above by saying 7 times 5 gave me 35. But I could also take all of these inside areas, 12 plus 9 plus 8 plus 6, and that also adds up to 35. So if you ever get stuck, you can always draw a picture and just add up all the smaller sections of the diagram. Which leads us to this question here. It says, based on your diagram, can the area of the garden be found in another way rather than multiplying? And we could say, yes, area can be found by adding the smaller sections. So based on your diagram, how would the area of the original garden change if you only increase the length? So if you remember the picture here, okay, I'm just going to draw like a little mini box. We had this situation where we had the 4 by 3. Now it's asking, what if they only added to the length the extra 3? So this was 12, which she already has. What did she gain over here? She gained an additional 9. So this would have only increased her square footage by 9 feet squared. All right, now the next question is asking the same similar thing. So I'm going to draw that box again just to give you a visual. And again, she originally had the 4 by 3. What if she only increased the width by the 2 and not the other side? Then she would have only gained that 8 extra square feet. So this would have only increased her square footage by 8 square feet. Now, if you're still a little confused on how we got those numbers, we're going to fill in this chart down below and it'll kind of all sum it up. So we're going to organize all the work that we've been doing up to this point in this nice chart. So her original garden was a 4 by 3. which gave her an area of 12, and that was without increasing anything yet. That was the original. Then she increased it by 3 by 2. She added 3 more feet to the length, 2 more feet to the width, which made it a 7 by 5, giving her an area of 35. Now, how much did that increase by? We take 35 minus 12, and that increased it by 23 square feet. Now, what if she had only extended the length? That would have been the 4 plus 3, which would have given me 7, but remaining with the original 3. So now my area is 21. So how much did that increase by? So we say 21, I should probably put these in parentheses, 21 minus 12, and that gives me 9. That's the answer we just got to E, from E. That's how we got 9 from E. Now, what if she only extended the width? So we're going to keep the original 4, and this time we're going to do the 3 plus the 2, so it's 4 times 5, which gives me 20. I'm going to come over here and do 20 minus 12, and that gives me 8, which is the answer we got for F. So it says, will the increase in both the length and the width of the 3 by 2 respectfully mean the original area will increase strictly by the areas found in E and F? So will it only increase by 9 and by 8? And that is no. It also had that little bonus square. So it also includes an additional 6 by 6, or not 6 by 6, excuse me, a 3 by 2, which was a 6 square feet. I was thinking square feet and I wrote 6 by 6, so square feet. She got an additional 6 square feet because she went ahead and squared it off. All right, let's go ahead and move on to the next one here. Now this one here is purely an example, and what they're doing is basically showing you that we had a image, we had a garden, let's say, which was a 4 by 4, and that 4 by 4 gives me an area of 16. And then over here they increased it by 2, which is now 2 by 4, which gives me an area of 8. Here again is a 4 by 2, which gives me an area of 8. And then there's that little bonus section, which gives me an area of 4. We don't have to do anything with this. They're just kind of giving it to you as an example of what you're going to draw. So now we're going to draw another box, just like the one up above. Let me make that a little bit bigger. All right, and kind of divide this up, but again, don't have it go right down the center because visually you won't be able to see it so well. So this is going to be a 3-unit square. It says square, so that means this is a 3 by 3, and it's increasing both of the sides by 2. So a 2 and 2. So what is my area of the original? That's going to be 3 times 3. So my area of the original is 9 here. Now remember, go down the row, which is 3, to the column, which is 2, and that gives me a 6. Here the row is 2, column is 3, that gives me an area of 6. And then we have a 2 by 2, which gives me an area of 4. Now again, I could do 9 plus 6 plus 6 plus 4, or I can see that this 3 plus 2 gives me 5. 3 plus 2 gives me 5, and I can say that my area is length times width, which is 5 times 5, which gives me 25 feet squared. Now the next one, you guys are going to do on your own. So this is going to be one that I grade. So I'm going to let you guys do B. B is just like A, just with different numbers. And again, C down here is just an example, but what we do want to show you is that even with variables, you wind up A times A is A squared. A times B is AB. Okay, so this is A times A. And this is A times B. And then down here is again A times B. And then this is going to be B times B, which gives you B squared. So on the sides here, I have A plus B, and down here I have A plus B. So if I was to find the area, it would be A plus B times A plus B times A plus B, which is basically A plus B squared. And that's as far as we can take the problem because we don't know what A and B are. Okay, that brings you to the 2 that you're going to do on your own here, but I'm going to kind of help you out here. You're going to draw a box that is a 10 by 10, and then it's increasing by X units, all right? And its width is increasing by 2. So you want to make sure that you create a box here. So you're going to have some variables in here. Then it says down here to go ahead and solve that you have the whole area is 156. See if you can figure out what that X actually is. So these 2 I will grade. That ends this video tutorial.